A transformer is a static device which consists of two or more stationary electric circuits interlinked by a common magnet circuit for the purpose of transferring electrical energy between them while keeping the frequency of operation constant. Basic principle behind the transformer action is Faraday's law of electromagnetic induction. Transformer is a constant frequency and constant power device. Induced EMF. Direction of induced EMF can be found by Lenz's law, and magnitude of induced EMF can be given by Faraday's law of electromagnetic induction. RMS value of induced EMF in primary winding E1 equal to 4.445 Fn1 volts. Once again, E1 equal to 4.445 Fn1 volts. In secondary winding, E2 equal to 4.445 Fn2 volts, where N1 equal number of turns in primary winding, N2 equal number of turns in secondary winding, Φm equal to maximum value of the magnetic flux in Webers, F equals supply frequency in H. EMF per turn in primary equal to EMF per turn in secondary. Compensating primary MMF equal to secondary MMF. I1 dash N1 equal to I2 N2, where I1 dash equal to load component of primary current I1. Primary volt amperes equal to secondary volt amperes. Instantaneous power input into primary is equal to the instantaneous power output from the secondary. Step up transformer N1 less than N2. Step down transformer N1 greater than N2. Ideal transformer. The transformer core has infinite permeability, so flux established without any magnetizing current. The primary and secondary windings have zero resistance, so there is no ohmic power loss and no resistive voltage drop. There is no magnetic leakage flux. The core loss consideration to be zero. Equivalent circuits. Equivalent circuit consists of R1, JX1 రెండు సిరీస్లో ఉంటాయి. నెక్స్ట్ దానికి ప్యారల్గా R0, JXM రెండు ప్యారల్లో ఉండి దానికి ప్యారల్లో ఉంటుంది. దానికి ఒక కాయిల్ ఉంటుంది. కాయిల్ దగ్గర వోల్టేజ్ E1. దాని ప్రైమరీ వైండింగ్స్ ఇస్ N1, సెకండరీ వైండింగ్స్ ఇస్ N2, అండ్ N2కి సిరీస్ విత్ R2 and JX2. The voltage taken as V2 bar. R1, JX1 దాని ప్యారల్గా R0, JXM, మళ్ళీ దాని సిరీస్గా R2 డాష్ JX2 డాష్. దానికి వైండింగ్కు ప్యారల్గా వోల్టేజ్ V2 డాష్, N1, N2 దగ్గర V2 డాష్, where V1 is applied voltage to primary side, V2 dash means secondary terminal voltage referred to primary side. E1 bar, E2 bar gives you induced EMF in primary and secondary windings. E2 dash equal to secondary induced EMF referred to primary side. I0 dash equal to no load current. II equal to magnetizing and core loss component of exciting current. R1, R2 primary and secondary winding resistances. X1, X2 primary and secondary winding leakage reactances. R2 dash, X2 dash secondary resistances and leakage reactances refer to primary side. R0 means core loss equivalent resistance. XM means magnetizing reactance. At no load current drawn from the supply is I0. I0 equal to Im plus Ia, that equal to 5% of IFL. Im equal to I0 sin phi 0 equal to magnetizing current and is responsible for the production of flux. I equal to I0 cos phi 0 equal core loss current responsible for the active power being drawn from the source to provide hysteresis and eddy current losses. Phi 0 equal no load phase angle 80 to 85 degrees. Secondary side parameters refer to primary side. If N1 by N2 equal to A, secondary resistance refer to primary side. R2 dash equal to A square R2. Secondary leakage reactance refer to primary side. X2 equal to A square X2. Secondary current refer to primary side. I2 dash equal to I2 by A. Secondary induced EMF refer to primary side. E2 dash equal to A V2. Secondary terminal voltage refer to primary side. V2 dash equal to A V2. Basic equation for transformer. E1 equal to A V2. I0 equal to Im plus Ii. E2 equal to V2 plus I2 R2 plus J I2 X2. V1 equal to E1 plus I1 R1 plus J I1 X1. I1 equal to I2 by A plus I0. I2 by A is separate to plus I0. Phasor diagram. R01 equal to R1 plus R2 dash equal to equivalent resistance referred to primary side. X01 equal to X1 plus X2 dash equal to equivalent reactance referred to primary side. Z01 equal to root over R01 square plus X01 square, that equal to equivalent impedance referred to primary side. Core of transformer should have low reluctance and high permeability. It is made from CRGO, cold rolled grain oriented material with 4% of silicon. It is laminated to reduce eddy current losses. Types of transformers construction: core type, shell type. Core type transformer, shell type transformer. First one, core type transformer, series magnetic circuit. Core type transformer, 2 limb and 2 yoke. Core type transformer suitable for low flux density and application. Core type transformer require more amount of copper. Core type transformer requires less amount of insulation, so suitable for high voltages and high power applications. Shell type transformers, parallel magnetic circuit. Shell type transformer, 3 limb and 2 yoke. Shell type transformer suitable for high flux density applications. Shell type transformer requires less amount of copper. Shell type transformers are suitable for low voltage and low power applications. Transformer windings are made up of stranded conductors instead of solid conductors. Low voltage windings are placed nearer to the core for reducing insulation requirements. Losses in transformers, copper loss, PCUP. This loss is variable loss. Total copper loss equal to primary copper loss plus secondary copper loss. PCU equal to I1 square R1 plus I2 square R2. Resistance referred to any one side. PCU equal to I1 square R01 equal to I2 square R02. PU resistance equal to PU full load copper loss, iron loss, PI. This loss is current constant loss. Iron loss equal to hysteresis loss plus HB current loss. Hysteresis loss, pH equal to KHF BMX. BM, where BMX means that is the indication. B base M whole power M X. B base లో M ఉంటుంది, పైన X ఉంటుంది. KH means proportionality constant, depends upon the volume, quality of the core material and units used. BM means maximum flux density in the core. F supply frequency. X steam edge exponent, value varies from 1.5 to 2.5, but BM is directly proportional to V by F. If V by F equal constant, pH is directly proportional to F. If V by F is not equal to constant, pH equal to A into V power 1.6 F power minus 0.6. If X equal to 1.6, that is for silicon steel. Hysteresis loss, pH equal to KHF BMX. KH means proportional to constant, depends upon quality of the core material and units used. BM means maximum flux density in the core. F means supply frequency. X means steam edge exponent, value vary from 1.5 to 2.5, but BM is directly proportional to V by F. If V by F equal to constant, pH is directly proportional to F. If V by F is not equal to constant, pH equal to A into V power 1.6 F power minus 0.6. Eddy current losses, PE equal to KE into F square BM square T square, where KE means proportional to constant, depends upon volume and resistivity of core material, thickness of laminations and units employed. F means supply frequency, BM means maximum flux density, T means thickness of lamination, but BM is directly proportional to V by F. If V by F equal constant, P is directly proportional to VF square. If V by F is not equal constant, P is directly proportional to V square, or P equal to BV square, where B equal constant. The iron loss can be reduced by reducing the core flux density, which means that for same flux the core cross sectional area must be increased. Size of distribution transformer is larger. Size of distribution transformer is larger as compared to similar power transformer, as iron to copper ratio of distribution transformer is higher. Stray load loss, it largely results from leakage flux, including eddy currents in the tank walls, conductors, etc. Dielectric loss, this loss is in the insulating materials, particularly in transformer oil and solid insulations of high voltage transformers. Rating of transformer is given in kilovolt kVA because constant loss is proportional to voltage and variable loss is proportional to current, so total loss in transformer is proportional to volt ampere. Open circuit test and short circuit test. These two tests on transformer helps to determine the parameters of the equivalent circuit, voltage regulation, efficiency. They help in predicting performance of transformer without actually loading it. Open circuit OC test. Main object of the test are to find out parameters of no load branch, that is R0 and XM of equivalent circuit. షంట్ బ్రాంచ్ పారామీటర్స్ ఎలా వస్తుంది అంటే వోల్టేజ్ అనేది ప్యారల్ వస్తుంది ఏసీ సప్లైకి. ఏ సిరీస్లో ఏ వస్తుంది, డబ్ల్యూ ఒక వైండింగ్, కింద వైండింగ్ వచ్చి ఆ ఎల్వీకి ఏమో ట్రాన్స్ఫార్మర్ ప్రైమరీ సైడ్ వస్తుంది, ఇంకోటేమో షార్ట్ అయిపోతుంది గ్రౌండ్కి. హెచ్వి సైడ్ ఏమో ఒక వైండింగ్ వచ్చి ప్రైమరీ సెకండరీ వైండింగ్ వచ్చి ఓపెన్లో ఉంటుంది. Main objectives of this test are to find out parameters of no load branch, that is R0 and XM of equivalent circuit. Shunt branch parameters to find out constant losses in the transformer, that is core loss. Open circuit test OC test. Main objective of this test are to find out parameters of no load branch, that is R0 and Xm of equivalent circuit shunt branch parameters to find out constant losses in the transformer, that is core loss. This test must be conducted at rated flux condition, that is at rated voltage and rated frequency. This test is performed on LV side while HV side is open circuited. Sequence of equations used to find different parameters. Wattmeter reading equal to PI core loss or iron loss. Voltmeter reading VOC rated voltage. Ammeter reading I0 no load current. No load power factor equal to cos phi naught. In this circuit is R0 is parallel with JXM. PI equal to VOC I0 cos phi naught. Cos phi naught equal to PI in numerator VOC I0. II equal to I0 cos phi naught and Im equal to I0 sin phi naught. R0 equal to VOC by II and Xm equal to VOC by Im. Short circuit test. Same like input is variable low voltage supply is connected parallel with VSC in series with A, W, small winding and big winding. Small winding is connected to the primary side of transformer, big winding shorted. HV higher voltage is in transformer condition. LV thick line. LV దగ్గర షార్ట్ సర్క్యూట్ చేసేసి థిక్ లైన్ వస్తుంది. మెయిన్ ఆబ్జెక్ట్ ఆఫ్ దిస్ టెస్ట్ ఆర్ టు ఫైండ్ అవుట్ total resistance and reactance of transformer when referred to the winding in which the measuring instruments are placed to conduct this test to find out variable losses in the transformer, that is copper loss. This test should be conducted at rated current condition. This test is conducted HV side while LV side is short circuited with a thick conductor. R1 X1 ISC X2 R2 VSC, that equal to VSC R equivalent JX equivalent. Wattmeter reading equal to PSC in brackets rated copper loss. Voltmeter reading equal to VSC. Ammeter reading equal to ISC in brackets rated current. Sequence of equations used to find different parameters. R equivalent equal to PSC by ISC square. మాత్రం ISC square మాత్రం ఉంటుంది. Z equivalent to VSC by ISC. X equivalent equal to root over Z equivalent square minus R equivalent square. R equivalent, X equivalent and Z equivalent are referred to high voltage side. Power factor on short circuit cos phi SC equal to R equivalent by Z equivalent. Back to back or Sumpon's test is used to determine maximum temperature rise of transformer. Efficiency eta equal to output power by input power, that equal to output by whole by input ఏమంటే పవర్ ఉంది కదా, అవుట్పుట్ ప్లస్ లాసెస్. eta full load equal to KVA full load cos phi by అది న్యూమరేటర్ పార్ట్, KVA FL cos phi న్యూమరేటర్ పార్ట్ by denominator part KVA full load cos phi plus PI plus PCU full load, where PI means core loss or iron loss, PCU full load means full load copper loss. Efficiency at any fraction x of full load. Efficiency of x at full load equal to x of KVA full load cos phi whole by x of KVA full load cos phi plus PI plus x squared PCU full load. న్యూమరేటర్ పార్ట్ ఏమంటే x of KVA full load cos phi, denominator part ఏమంటే x of KVA full load cos phi plus PI plus x squared PCU full load. Condition for maximum efficiency, copper loss equal to iron loss. I eta max equal to root over PI by R equivalent. KVA load for maximum efficiency, S eta max equal to S known load equal to root over PI by PCU known load. S known load అది పక్కన పెట్టేసి ఇంటూ రూట్ ఓవర్ అదేం PI by PCU known load. S eta max equal to KVA rating at maximum efficiency. S known load equal to KVA rating at known load. PCU known load equal to copper loss at known load. For full load, S eta max equal to S full load into root over PI by PCU full load. All day efficiency eta all day equal to output energy kilowatt hours in 24 hours by input energy kilowatt hours in 24 hours. The maximum efficiency for a constant load current occurs at unity power factor. The maximum efficiency for a constant load current occurs at unity power factor. Efficiency is independent of type of power factor. Voltage regulation. Voltage regulation of transformer is defined as the rise in output secondary voltage expressed as the fraction of full load rated voltage when full load at specified PF is reduced to zero, keeping the primary impressed terminal voltage constant. Once again I will repeat. Voltage regulation of transformer is defined as the rise in output or brackets low secondary voltage expressed as the fraction of full load rated voltage when full load at specified PF is reduced to zero, keeping the primary impressed terminal voltage constant. Voltage regulation equal to no load voltage minus full load voltage by full load voltage, where full load voltage is rated voltage. Regulation is always calculated at full load and should be as low as possible. Approximated equivalent circuit referred to secondary voltage regulation. VR equal to I1 R1 equivalent cos phi whole by V rated plus ఇదంతా ఒక పార్ట్ ప్లస్ I1 X1 ఈక్వలెంట్ sin phi by V rated. కరెంట్ రిఫర్ టు సెకండరీ కదా. R1 ఈక్వలెంట్ అండ్ JX1 ఈక్వలెంట్ సిరీస్లో పెడతాం. ఇన్పుట్ ఏమో V1, అవుట్పుట్లో ఏమో V2 డాష్. VR V డాట్ R ఈక్వల్ టు RPU cos phi plus XPU sin phi, where phi is the angle between V2 dash and I1. RPU means PU equivalent resistance, XPU equal to PU equivalent reactance. Phi is positive for lagging power factor and negative for leading power factor. Condition for maximum voltage regulation, cos phi equal to RPU by ZPU, that equal to R1 equivalent by Z1 equivalent lagging. Maximum voltage regulation, VR max equal to ZPU. Condition for zero voltage regulation, cos phi equal to XPU by ZPU, that equal to X1 equivalent by Z1 equivalent leading. For leading power factor greater than XPU by ZPU, the voltage regulation will be negative. Regulation is always positive at all lagging power factors loads and also at unity power factor load. Regulation may be positive at large leading power factor near to unity, and regulation is negative at low leading power factor away from unity. Auto transformer AB equals series winding, BC means common winding, NH means number of turns in winding AC, NL means number of turns in winding BC. Ratio of transformation, A auto equal to VH by VL equal to NH by NL. Always try to keep A auto closer to 1, that is A equal to 1. In worst case, we try to keep A auto equal to 3:1. Since there is no electrical isolation between primary winding and secondary winding, so when there is common winding is open circuit, then full high voltage appears across low voltage winding at the time of step down mode. Comparison between two winding transformer and auto transformer. Copper white Cu white auto equal to 1 minus of 1 by A auto, 1 separate to minus 1 by A auto, then into full into copper white base to WDG. Copper saving equal percentage copper saving equal 1 by A auto into 100. KVA rating of auto transformer, KVA auto equal to A auto by A auto minus 1. A auto minus 1 is the denominator into KVA to WDG, అదంతా ఫుల్ ఇంటూ అనమాట. KVA auto equal to KVA rating of auto transformer. KVA to WDG means KVA rating of two winding transformer. Inductive and conductive transfer, VL equal to VL into IL minus IH plus VL into IH. Inductive transformer, conductive transformer. Transfer, inductive transfer by total transfer equal to 1 minus 1 separate minus of 1 by 1 by A auto. Conductive transfer by total transfer equal to 1 by A auto. Auto transformers has higher efficiency, lower PU impedance and lower voltage regulation as compared to two winding transformer, three winding transformer. Voltage per turn మొత్తం కాయిల్ వచ్చేసి N2 N3, V1 by N1 equal to V2 by N2 equal to V3 by N3. MMF balance equation, N1 I1 equal to N2 I2 plus N3 I3. Neglect magnetizing current. I1 equal to N2 by N1 into I2 plus N3 by N1 into I3. That is also called as I1 equal to N2 I2 by N1 plus separate plus N3 I3 by N1. KVA balance equation, V1 I1 equal to V2 I2 plus V3 I3. S1 equal to S2 plus S3. Three winding transformer can be used to interconnect power systems at different voltage levels. Tertiary winding is used as supporting winding in Y-Y transformer to stabilize neutral and to avoid third harmonics. Application of different connection, delta by delta. This connection is used where we have simple 3-phase load, especially at low voltage level. No mixed loading possible. Y bar delta. This connection is used to for step down applications. Delta bar Y. This connection is used for step up application except in distribution system where delta bar Y is used for step down transformer step down application for mixed loading. Y bar Y. This connection is quite attractive for HV applications. It is not generally used without a tertiary delta. Condition to be satisfied for parallel operation. Must condition, same polarity, same voltage rating, same phase sequence, zero phase difference, which means transformer belongs to same phasor group, can only operate in parallel. Desirable conditions, same X by R ratio for same power factor operation, same PU impedance on their own KVA base for proportional load sharing. Electromagnetic system, magnetomotive force MMF equal to number of turns in the coil into current.
magnetic flux phi equal to mmf by reluctance. Reluctance means opposite offered by the magnetic flux is called reluctance. R equal to 1 by mu a, where R means reluctance, L means length of magnetic path. R equal to L. L అనేది న్యూమరేటర్, mu a అనేది డినామినేటర్. R equal to L by mu a. R means reluctance, L means length of magnetic path meter, A means area of cross section normal to flux path meter square, mu means mu naught mu r, permeability of the magnetic material, mu r means relative permeability of the magnetic material.
Self-inductance. The self-inductance L is defined as the magnetic flux linkages per ampere. L equal to Xi by I. Magnetic flux density B equal to magnetic flux phi by cross sectional area A, Tesla or Weber per meter square. Magnetic field intensity H equal to mmf by mean length of magnetic circuits, H equal to mmf by L, At bar m. Relation between magnetic flux density and field intensity, B equal to mu H. Energy density in electric field, WD equal to integration of 0 to d E bar dot ddd, that equal half d square 2 epsilon naught, where d equal to electric flux density, E means electric field intensity or potential gradient, d equal to d by epsilon naught.
Once again I will repeat. Energy density in electric field, WD equal to 0 to d integration of 0 to d E dot d dd equal to half d square by epsilon naught, d square by 2 epsilon naught we can say. D means electric flux density, E means electric field intensity or potential gradient, that equals d by epsilon naught. Basic concepts in rotating electrical machines. Introduction. Electromagnetic torque, also called interaction torque. T is directly proportional to stator field strength into rotor field strength into sine delta. Interaction torque T is directly proportional to stator field strength into rotor field strength into sine delta, where delta means torque angle. Electrical and mechanical degrees. Theta electrical equal to P into theta mechanical whole by 2. Theta electrical means angle in electrical degree, theta mechanical means angle in mechanical degree. P means number of poles. P means number of poles. Pole pitch. The peripheral distance between adjacent poles is called pole pitch. It is always equal to 180 degrees electrical degrees. Average value of flux density wave over one pole pitch, B average equal to 2 bp whole by pi, where bp means maximum flux density. Total flux per pole, phi equal to 4 bp rl whole by p, where L means axial length of the armature core, R means radius of armature core. Generated EMF in a full pitched coil, E equal to n omega r phi sin omega rt. N means number of turns in single full pitched coil, phi means flux per pole, omega r means relative velocity between field flux wave and armature coil. RMS value of generated EMF in a full pitched coil, E equal to 4.44 Fr n phi, where Fr means rotational or speed frequency. Rotational frequency F equal to Fr equal to P_nRh by 2. NR means relative speed between armature coil and flux density wave in RPS. Generated EMF in a short pitched coil, E equal to 4.44 kp Fr n phi, where kp means coil pitch factor or coil span factor or pitch factor. Pitch factor kp equal cos epsilon by 2. Only angle epsilon by 2 ku half cos, where epsilon A equal to angle of chording or pitching for fundamental flux wave. DC machines. DC machine is a flexible and highly versatile energy conversion machine. It can easily supply the demand of loads requiring high starting torque, high accelerating and high decelerating torques. DC machine is also suitable for drives requiring wide range of speed control. Classification of DC machines. DC machines, permanent magnet, separately excited, self-excited. Separately excited లో 2 types, voltage excited, current excited. Self excited లో 3 types, series shunt, compound machine. Compound machine లో 2 types, long shunt, short shunt. Compound machine లో 2 types, cumulative compound, differential compound. Separately excited field winding is energized by an external DC source. Self excited field winding is excited by its own armature. Series field winding is thick, has small number of turns and carry large current. Shunt field winding is thin, has large number of turns and carry less current. EMF generated in the armature, EA equal to phi Zn into P whole by 60A, that equal to K phi omega m, where phi means flux per pole, Webers. P means number of poles, Z means number of conductors, A means number of parallel paths,
that equal P for lap winding is equal to 2 for wave winding. N means speed in RPM, omega m means 2 pi n by 60, mechanical angular velocity, mechanical radians per second, K means Pz by 2 pi a, that equal constant of the machine, K equal to Pz by 2 pi a, constant of the machine. Torque equation T equal to K phi Ia equal to Ia by omega m, where T means torque developed in Newton meters, Ia means armature current. Circuit model లో RT, EGRA load, that is generator, motor దగ్గర RF, EBRA, VT equal to EG minus IARA for generator, V equal to EB plus IARA for motor. VT means terminal voltage, V means supply voltage to motor, EG means generated EMF, EB means back EMF, RA means armature resistance, RF means field resistance, IA means armature current, IF means field current, IL means load current, EG equal to EB equal to EA equal to voltage developed in armature. Generated EMF in generator is called back EMF in motor. Power balance in DC machine. Generator action, shaft power input minus rotational losses gives armature power developed, EAIA minus all copper losses including brush drop gives you electrical power output. Motor action, electrical power input minus all copper losses including brush drop gives you armature power developed, EAIA minus rotational losses gives you shaft power output. Armature power developed, PA equal to EA into IA. Efficiency, eta equal to 1 minus of losses by input power 1 separate to minus of losses by input power separate equal to output power by input power, that equal to output power by output power plus losses. DC generator, eta G equal to output power by output power plus losses, eta G equal to VTIL whole by VTIL plus I square R plus VBDI plus PK, where VTIL is output power, I square R means total ohmic losses, PK means constant losses, VBDI means brush contact losses, VT means output voltage, IL means load current. DC motor, eta M equal to input power minus losses by whole by input power, eta M equal to numerator part చెప్తున్నా ఇదంతా, VI minus of I square R plus VBDI plus PK, that is nothing but numerator part ఏమంటే VI minus I square R minus VBDI minus PK whole by VI, where VI is input electrical power. For generator and motor, maximum efficiency occur when constant loss equal to variable loss, PK equal to I square R ohmic loss. Maximum power output by DC motor when EA equal to V by 2 and IA equal to V by 2 RA. When motor operates at maximum power output, it gives only 50% efficiency. Characteristics of DC generator: no load or magnetization characteristic or open circuit characteristics, OCC. Magnetization characteristics gives the variation of generator voltage or no load voltage with field current at a constant speed. Internal characteristics: it is plot between the generator voltage and load current. Load or external characteristics between terminal voltage Vs versus load current IL at a constant speed. OCC does not start from origin due to the presence of residual magnetism. Characteristics for separately excited generator: voltage EA, delta VAR, armature reaction drop. External characteristics: these graphs all comes under characteristics of DC motor. Constant characteristics for series generator: constant current region is suitable for welding. Series generator is used in booster region for line drop compensation. Characteristics of DC motor: speed versus armature current, N versus IA, torque versus armature current, T versus IA, speed versus torque, N versus T. In a traction system, we use series motor where high starting torque is required. Characteristics of DC compound motor: magnetic flux has a tendency to follow a minimum reluctance path. Exciting or field windings produces the work flux or main flux. In armature winding, the work EMF is induced by working flux. For the development of electromagnetic torque in all rotating machine, the number of rotor poles should be equal to the number of stator poles. Voltage buildup fails in generator if residual flux absent, field connection is wrong, reverse IF destroys phi or residual, direction of rotation is wrong, field resistance is more than critical field resistance, speed less than critical speed. In DC machine, the field winding is on the stator and armature winding is on rotor.
Commutator serves as for DC generator, mechanical rectifier, for DC motor, mechanical inverter. DC series motor never runs at no load.
Armature reactions.
The effect of armature flux on the main load flux distribution in the air gap is called armature reaction. The armature MMF produces two undesirable effects on the main flux: net reduction in the main field, distortion of the main field flux wave along the air gap periphery. The effect of armature flux on the main field is cross magnetizing as well as demagnetizing. Flux created by the armature MMF is called cross flux. Phi R equal to phi A bar plus phi F, where phi P means flux produced by field MMF, phi A means flux produced by armature MMF, phi R means resultant flux. Magnetic neutral axis MNA is always perpendicular to the axis of resultant field flux. Geometric neutral axis is along the quadrature axis of the DC machine. Compensating winding MMF neutralizes the armature MMF only under the main pole phase. Interpoles are used to neutralize the armature reaction flux. In the interpole axis, it is also produce some rotational voltage in the coil, undergo commutation and neutralize the reactance voltage and improve the commutation. Polarity of interpoles is same as the succeeding main pole in generator action and of the preceding main pole in motor action. The interpole winding and compensating winding carry armature current. The interpoles are long but narrow in shape to avoid saturation. Speed control of DC machine. N equal to numerator part V minus IRA whole by denominator part K phi. Speed can be controlled by armature voltage control, constant torque drive. Speed control is possible only below base speed, that is N less than NB. Armature resistance control, constant torque drive. Speed control is possible only below base speed, that is N less than NB. Wide range of speed control is not possible. Field flux control. In field flux control, it is constant power drive. It is a field flux control. Speed control is possible above base speed, that is N greater than NB. The graph torque and power characteristics is combined armature voltage and field control.